Hello my friends, welcome again to my video channel. You see, one project is hunting the next project. Yaesu FT101ZD, shortwave transceiver from the late 70s of the last century. Again, a member of our local radio club asked me for some support. He has a problem with it. Suddenly no output. Receive is okay, no output. Couldn't be a big problem. But first some words about such a transceiver. It is a so-called hybrid transceiver. It means it is nearly fully transistorized, equipped with semiconductors, transistors, diodes, integrated circuits. In the beginning with the 70s, the manufacturer started to add more and more semiconductors into the transceivers, sometimes with negative effects. The IMD or IP3 of the receivers got worse with semiconductors in the front end, but that's not the topic today. There was still one problem: to get output power of 100 watt with transistors. They were available on the market in those days, but rather expensive and not very reliable, especially under amateur radio conditions with various antennas. OEMs have a tendency to try several antennas. That's okay. Radio amateur is an experimental technique, but this has a high danger that suddenly the transistor sees not 50 ohms, and when a transistor PA in those days does not see 50 ohms load, then it says goodbye. That's it, and it is expensive. So the PA and the driver stages are still equipped with tubes. Let's have a look into it. The FT101Z or ZD, D only stands for digital display. The FT101Z is the successor of the famous FT101 series of this manufacturer. The FT101E is similar, has not so much features, but the FT101Z is a little bit more sophisticated, has a little bit more options, bandwidth control, and so on. Of course, a digital display. The digital display is an option, but still it's, as I said, equipped with tubes in the output. We have here the standard. This is the output, tuning, plate and load. I will say some words regarding plate tuning. There's sometimes a misunderstanding. Some guys do kill the tubes when they don't know what plate is. Preselector bands which you see, they are not the new WARC bands, so-called new bands, still only the old bands. I know there is a version of this transceiver on the market which has these WARC bands. This one does not have, so I think it's late 70s or so. Well, it's very rugged, very heavy. We have here the preselector, filters, VFO, and here we have the output amplifier. This is a driver tube, 12BY 7A, as I've seen in the manual, and these are two 6146B connected in parallel, so the output power is 100 watt and more. There is a tuning circuit, and safety hint: the anode voltage here on the anodes and also on the capacitor and on this coil here is 900 volt DC. I repeat, 900 volt. And this means it is absolutely lethal, no discussion. The power behind it is very big. We have here a big transformer. Maybe you don't see it. The input power, DC input power of this stage here is 180 watt DC. Nominal, I think it's more than 200 watt. And you can imagine power with 200 watt at 900 volt DC. Okay, that's it. Goodbye. Never touch it. Always discharge these tubes best is to ground it. I will do it later. I will ground it with ground straps and disconnect the power transformer. But first I will do a test to check what's happening, because I fear that there's a problem, maybe in the tubes or in the driver stage. The rest is standard VFO. Here on this side we have the power supply. These are the connections to the loudspeaker, as I know. There are filters installed. I think SSB, CW, and one filter should be for AM, because the transceiver also has a mode AM, and I have seen in the papers that there's an option for an AM filter. And I see there's a fourth filter. Aha, okay. Ah, it's for the bandwidth control. When we have a bandwidth control, we need two filters to be shifted against each other. So there are four filters, Chrysler filters. Oh, okay. Took some money, yes. Yes, here have we AM, CW, wide narrow, and tune is a position to tune it. Well, if the owner told no output, first thing is I will check it, fire it up, connect the dummy load and see what happens. The transceiver is connected to my isolation transformer with Variac. The owner told me he measured some voltages, so I assume everything is okay. We don't have a problem with the power supply, but I'll be careful. I switch power on, also heater on. By the way, heater on off means not switch high voltage on off. It only disconnects the filament from the heater supply. The high voltage is connected to power, to this switch. I will increase the voltage. 0, 50 volt, 100 volt. Now you see the first LED. Some LEDs are appearing. 3700, okay. We are at 150 volt, go up to 200. Fan is running, can be tuned. Go a little bit more up to 20 to 30. Can be aligned, tuned, that's nice. I will check it with the marker. 3700, we should have a peak. Ah, okay. The preselector can be peaked. That's good. We are on the 80 meter band. That's also good. Seems to work. Let's go 25 down. The marker is again. Can be peaked again. So the receiver seems obviously to work, at least in the 80 meter band. I'm in mode LSB, USB. We don't hear a tone, we have no loudspeaker connected. That's not important at the moment for me. Now I've connected the dummy load, of course. Now I go into the mode. Is it tune? No, tune is now here. And the meter is set to IC, not output power or ALC, it's set to IC. That means cathode current. IC is cathode current. The current through the final tubes is measured on the cathode resistor on the voltage drop. But there is nothing. There should be at least a little bit of current. Cannot get any drive control. Should be possible with the drive, with the control of the drive, to get some current, which can be dipped, but there is no current. And I didn't hear a relay clicking. As I understand, in the mode tune there should be a relay reacting, clicking, the transmit relay or antenna relay. Nothing happens. Suspicious, suspicious. Why is this relay not clicking? It cannot be heard. For measuring high voltages, you need an appropriate equipment. This is a high voltage probe, 1000 to 1, that means 1 kilovolt here is 1 volt in the output. It can be set to 10 or 1 megohm. I set it to 10 megohm, that's the input impedance of this little meter. And it is specified up to 15 kV. 15 kV, that means DC plus peak voltage of AC. 1000, that means when we have here 1 volt, we have a 1000 volt. We have here approximately 900 volts. I will touch it now. We see here 0.9 or 900 millivolt. I don't know what the instrument will show. Now I touch it. 0.904, that means 900 volt. I check the other one. It's also 900 volt. So I switch the power off. Now we can observe when we switch power off how fast or how slow the the capacitors discharge. If you have millivolts, it's still 280 volt. There are bleeder resistors in parallel which discharge the electrolytics, but it takes some time, as you see. First, read the manual. Tune, and then set it to max. The Vox gain should be set to max. And now we have 100 milliamps is a lot of current. Now I'm trying mode CW. The Vox gain is okay. They said that there's a reaction of the Vox. I can increase the output power. We have here the output power. Full scale is 200 watts, 100 watt is approximately here. Not so important how many watts it is. You hear something of the power transformer. I can increase the power. That's 100 watt now. 300 milliamps. Okay. But it works. Let's go to SSB. Now I have mode SSB, microphone connected. 1, 2, 3, output power is also present. Microphone gain can be set here. There is a processor inside. Ah, the processor does not operate. One, two, three, nothing output, no output. When you switch the processor off, there's an output. Ah, okay, maybe the owner meant that the processor is not working. 1, 2, 3. A little bit can be seen. Minimum output power. I now only have 20 watt full output on the power meter. That's 2 or 3 watt. Well, it seems that the processor is not working. The rest is okay. Now I will check the other bands whether they're also transmitting. Meanwhile, I talked to the owner. It seems there was a big misunderstanding. Let's call it misunderstanding. He did not use this transceiver for many years, and then he took it out of the storage, and then he thought it was not transmitting. I asked him, did he use a drive control? he hesitated with his answer. Okay, I told him that obviously the processor is bad. Okay, check it. He told me I will do it. I'm quite sure that the problem is not the transmit stage. Now I'm in the 40 meter band. When we go to tune, increase the power, we can dip the current with load, with plate, increase the power with loading, then increase it, pre-selector for maximum, I think it's okay. Let's use CW. With 80-90 watts. Okay. Meter band. Let's go to tune. Pre-select, pre-select. Plate dipped. Output maximized. Then drive control for maximum. Then we can increase the output power. Dip with plate, it's always important. Then increase it 80-100 watts. That's also okay. $80 watts also on 10 meter. Well, that's it. I think the transmit stages are okay. We can focus now on the processor. But to do the work on this transceiver, I will first, oh yes, really getting warm, yes, some heat. I have to switch off the high voltage, unsolder it, and I can show it in the manual. Here we have the voltage doubler for the 900 volt, 320 volt RMS. That's 450 volt peak is connected, and it's a voltage doubler. And the center of this transformer winding is connected to the center of the two capacitors. So we have a voltage doubler. I will disconnect this voltage with 320 volt, and then the complete high voltage is dead, and I can make a short circuit and connect it to ground. I've disconnected the 320 volt in feed, this red wire, unsoldered it. This was a pin, 320 volt input. It's in a transparent plastic tube. That's good enough, not just to avoid any contact of this voltage of the 320 volt AC to any other pin. And here in the PA, you see this from the anode, plus 900 volts to ground, a big ground strap. This is my safety belt, necessary to survive. That's it. The other voltages are 150 or 180 volt for the driver tube. They are on another board. I will simply cover it with a big paper. Here we have the high voltages for the driver tube, 300 volt, and the grid voltages, screen grid, and here we have the, I think it is BIOS setting. I will cover it this way with this hard top, you can say, and I will fix it with some tape so it is also protected. That's it. Now the transceiver is made safe. All precautions are made, covering this high voltage board, ground strap, unsoldered the AC for the voltage doubler. I will switch it on and then fire it up with the Variac and see whether there's any sign of smoke or so. You may think that's a little bit too much what I did here with this and this and this, but when I was at university decades ago, some of the guys of the professors or tutors showed us pictures from guys who electrocuted themselves or have been killed by the fault of another one. Partially ugly pictures, very ugly. I don't want to be another picture in this Hall of Fame. Not my intention. Well, switched on, connected. I increase the voltage and have a look at the current. Nothing happens. 100, 150 volts. Fan is running. 200. The current is 200 milliamps AC. Heater is of course switched off, also 230 volt, that's okay. I took out this board. This is the noise blanker, and this is the two fixed channels with crystals part. Crystals, we don't need it for the check. This filter here is not the AM filter as I thought first, it's a filter for the bandwidth. For the variable bandwidth is a 10.7 MHz filter. The other filters for SSB and CW have 8.9 MHz. So the trick is to convert this frequency up into this frequency. There's an oscillator on board with approximately 19 MHz. So the difference between this oscillator and the frequency 8.9 is 10.7. So the frequency from here is converted to this and then fed through this filter and then converted down to this frequency again. And with this trick it's possible to shift the two filters, this and this, against each other, and then we have a variable bandwidth. Not a topic in the moment. Here we have the filter for the processor, speech processor. That's located here. And we have some transistors around, switching diodes, which switch on and off this part. The trick is to clip the signal, the transmit signal. There is an integrated circuit. I assume this is a clipper. Feed it through this filter. So the clipping products outside the frequency of this band filter are rejected, and we get a rather clean signal out, which is clipped. It has a reduced dynamic. So this is the method in those days, and even in our days with analog filters, it's made in the same method. Here we will have a problem, assuming a problem. Let's have a look into the schematic. Here we have the part of the processor. The double sideband signal from the balanced modulator is coming in here. It is filtered. Here we have the SSB and CW filter. And then there are two paths. One path is a bypass, blue line. There are two diodes, this diode and this diode. They are switched on via this coil, positive voltage. So the signal is bypassed and goes through this transistor to the transmit IF and then to the mixer. When the processor is off, this is a path. When the processor is on, these two diodes are blocking and the signal goes through this transistor, this integrated circuit, where it is clipped. Here we have another, it's an emitter follower only, as I see. Yes, here we have the filter and this is the output. So the path for the processor is this path, and bypass without processor this path. And we can assume that we have a problem inside here because this is okay. Here is the problem. We have to check some voltages, DC voltages, where the diodes are working properly, all supply voltages are present. and other measurements. First measurements are the switching voltages, processor off and on. In mode processor off, here we have the positive voltage, which switches on via this inductor here. These two diodes, this diode and this diode, and we have the bypass. Obviously it works. In the mode processor on, we have here positive voltage, which supplies the supply voltage to the transistor and IC, and also switches on this diode here. This diode is also switched on. Here there is no switching diode on the input. The FET transistor has no supply voltage when the processor is off, so it is not existing. It's a high impedance input, not a problem. So we have only in the output behind the filter a switching diode. So I will check this voltage, of course it will be okay, then this voltage, and see what the voltage is on this diode, and then also on the components here. First check is to measure the switching voltages on this connector, pin 9, 13, 12, 11, 10, 13, 12, 11, 10, 9 is this one. This is energized when the processor is on, okay. When I switch processor off, no voltage. Processor on, we have voltage. And the next pin, pin 8, is energized when processor is off. So it's a bypass, and when processor is switched on, this voltage disappears. So we have checked that the both switching voltages are okay. And now we can go to the diodes. The first diode I will check is diode D15. That's a diode in the processor chain. There's no need to check these diodes here because they are working. Theoretically, one of these diodes couldn't switch off and cause a high damping, but I will first check this diode D13 on the anode and cathode, whether it is energized when the processor is switched on. D13. First I check the diode D13 in the output of the processor chain. When the processor is switched off, the cathode has a voltage of 10 volt. That's okay, because this voltage is fed in from the diode D12, which is the bypass diode. On the anode side of this diode, I'm measuring 0, nothing. This is a resistor in series, and when I switch the processor on, we have here 9.4 volt. This is the anode side, and on the cathode we have now 7.5. There's a small voltage drop because there's a resistor in series. Not a joke, it's a resistor which causes some volt drop. That's okay. 7.5. And when I go to the anode of the D12, there is nothing. This is dead. Okay. So D13 in the output of the processor chain is okay. It's difficult, not to say impossible, to measure all voltages on this board because all the components, resistors, are painted and the space is very small between them, so I cannot go between the components to measure without the danger to cause a short. Even the smallest tip like this one is not good enough for this purpose, so I will take it out. And on the other hand, it would be necessary to take it out in the case of a repair. Whatever it is in this corner here, I have to take out this board. So I will do it now. I will flip it out, unscrew this unit. This is, as I see, the AM modulator. I unplugged it. It was from me. It's the AM modulator. And then I can take out this unit, 4 screws in the corner, and flip it out. The board, the IF board, is out. I could flip it out as expected. And now we can measure follow the signal. That's what I propose, not to measure DC voltages. We simply follow the signal when the processor is switched off and on, and then we can see what happens. First step, Our first checkpoint is the input of the filter. We have here the filter behind the clipper. By the way, this is the IC TI7060. It's an FM IC made for FM reception with a limiter. It's an FM limiter used for FM reception. This is also used here as a limiter for the SSB signal in transmit mode. And behind this limiter there's a filter necessary to delete all unwanted products, mixing products, harmonics and so. I check first at the input of the filter. So to check whether this chain is okay or not, I use a filter because this pin is rather easy accessible. We have it here. Here's the filter input. Scope is connected. And in the background we can see the scope. Switch the lamp off. Transceiver is on. It is in transmit mode with MOX operation. It's necessary to have it in transmit mode. I feed in a signal from my audio generator 1000 Hertz into the microphone connector that's here, this cable. Microphone gain is open, and when I switch on the processor we can see we have at the input of the filter a signal. We have it is 10 millivolt times 10 100 millivolt per division, so we have 100 millivolt peak. I can vary it with the microphone gain and also with the processor level can be adjusted. Okay, that's not the topic in the moment, but we see there is a signal. When I switch it off, of course the signal is bypassed. Then we have, as we have seen, this bypass, and here we have no signal, so the signal from the balanced mixer and filter is bypassed and goes to this one. So here we have a signal. Then let's go to the output of the filter. There's also a signal, nearly the same amplitude. Yes, same amplitude as the output of the filter. Interesting. Here we also have a signal. With this chain including filter is okay. Here we have a coupling capacitor. I go to checkpoint TP4, connect the scope to TP4, and test point 4 is this one. I have to, sorry, wrong button, AC coupling. Now we see the AC signal at test point in the mode processor on. When I switch the processor off, the signal is a little bit slower in amplitude, lower in amplitude. But this depends of course on the setting of the microphone gain and on the compressor level. When I increase it with the input signal of the microphone and switch to the compressor, it's not considerably higher. Okay, but I see in the output at test point 4 we have a signal, this one or this one going through. This is a little bit astonishing for me. I didn't expect this. So this path is also okay, and this diode is okay. So we have here signal test point 4. In both cases, compressor or processor on or processor off. So why do we have here a difference? Well, next step could be to measure the real output here at test point 12. This is the output transmit IF, TX IF. I will make a bigger picture to show it. One moment, could be better when I show it here. Okay, you can imagine now. This is the output TX IF, test point 12. So we can check between this point and this point what's happening, what's going on. when we switch it off and off, because we have here two inputs. We have here an ALC input, but this ALC input goes, okay, it goes to this stage. Sorry, ALC is the upper one. Okay, this goes here, and then we have a second one, drive. Okay, let's check it. The scope is now connected to test point 12. That's the output of the IF chain. Output where it goes to TXIF output. That's the test point 12. As we have discussed, we see on the picture. Processor is switched off. With microphone gain I can vary the output level. That's okay. When I switch to processor, I have to use a drive control. Interesting. When processor is switched off, the drive control has no effect. No effect. And when I go to processor, then I can, with the drive control, increase or decrease the output level. Processor off, processor on. What's going on? Did I make a mistake? Or do we have another problem when the board is in place? Is there a short circuit to ground or so? Some of the pins here are rather long, but the two distance holders, the four distance holders in the corners are relative big, relative high, so I don't think that this is a problem. Crazy. The transceiver is ready again. Summary: I couldn't find any fault. The problem is in front of the transceiver. I will explain it a little bit later, but in the moment I can say there are no problems inside this transceiver. It was a problem of the operation. I checked the processor switch. It's a 4-pole changeover switch. All is clear. Checked it with a continuity meter, a beeper. All is okay. All voltages are present as it should. I reactivated the high voltage power supply, removed the ground strip, the ground strip like this one. Resoldered the 350 volt AC. Now the transceiver is back to life. And now I'll show you what I assume what happened. First problem was the drive control. It cannot be tuned without drive control. When we switch to tune with MOX, we cannot get out any signal. When we tune, okay, there is a signal, output signal. This is the current, cathode current, but without this drive setting, we cannot get any output. Okay, we can say operator too stupid error, but I have to be careful when I say this. Mode SSB, USB or LSB. Microphone is connected. I go to transmit. When the microphone gain is open, we have sufficient output. I can indicate the output or the cathode current. It's all okay. And now I was switching on the processor. When I go to output, nothing happened. Then I thought the processor is not okay. When I switch it off, we have output. I can position output. With processor, no output. It's necessary when the processor is on also to use the drive control, you see. When I increase the drive, we have output. Drive is necessary when operating with a processor. Drive is not necessary when operating without processor. Without processor, the drive control is not activated. Doesn't matter whether it is on or off. Clockwise, counterclockwise, the drive control is not active in pure SSB mode, but in mode processor, we have to use the drive control also to get output. This was a little bit weird. In the manual it is stated, when switching on the processor, you use the drive control to get output. Read your manual, I can only say. So I can say with a little smile in my face, it's not an operator too stupid error, OTSE, it's TOTSE. Two operators too stupid error. The second operator is myself. In the first moment I didn't realize that it is necessary to use a drive control in mode processor. Now I know it. Well, I'm old enough to say, made a mistake, didn't realize it, but we had a project. And I think it's a nice project, in spite of the fact that there was no fault. I think it was a nice little journey through an old transceiver. And now I will make a second video about the tuning of such an old amplifier with tubes. It is obviously not clear to everybody how to operate such a transceiver, and when doing the wrong setting in plate and load, especially plate, that the tubes may be killed. But this is not part of this video, this will be part of the next video. And now we are at the end of this crazy project. There was no fault. Two operators didn't realize how to operate this transceiver. Now it's clear, I checked everything, it is working on all bands, all modes. There was never a fault. And I can say, okay, I didn't realize it in the first moment, but with a twinkling eye, I can say, sometimes something happens. Stay healthy, stay tuned, see you on this channel.